Hey YouTube, this is Michael from ZoneRobotics, and today I'm going to be introducing the zBot Video Robot Development System. It features affordable hardware, less than $100 US. It has a very low latency video feed with high frames per second. We host peripherals in the unit such as the analog to digital conversion. There's 6 of them. Multiple GPIO, about 10 different GPIO lines that you can control. Pulse width modulation for really high resolution control of motors, and we also have modules dedicated to just controlling servos for easy control of servos. We support multiple different platforms such as Linux, Windows, and Android, and there's a Java-based engine that the user can build his code on top of, as well as plenty of user examples that the user can also build their code on top of. The different parts of the zBot system that you can easily interface with are the time module that basically just keeps track of time, and there's the general purpose input-output module which allows you to turn things on and off. There's the pulse width modulation module that mostly deals with controlling your motors, specifically your motor's speed and how fast they go. There's an analog to digital conversion module, and you have 6 ADC lines that you can connect to light sensors or any other type of sensors to get a high resolution feedback. There's the camera module, which you can interface with to change the resolution, brightness, or turn on one of the many camera effects. There's the COM module, which pretty much works on its own, but it handles the communication back and forth from the zBot to the client, be it a PC or an Android phone or any other type of device that supports Wi-Fi in the protocol. There's the log module, which takes care of logging everything that's going on. There's a servo module, which supports 8 servos, and you can easily send simply the degree that you want the servo to be at, and it'll set the servo to be at that position. There's the control module, which handles the order in which the other modules are processed and how often they're processed. The communication with the zBot is very simple. We use our own protocol, which is called the zCom protocol, and basically all it is the identifier, the function or module that you want to interface, the command you want to send to it, and then the new data. For example, if you wanted to change the resolution of the camera, you could just pass 5.3 and then the resolution that you wanted to send. Now each resolution is going to be a different number, like 1 might be 320 by 240 and 2 might be 640 by 480. But all of these are listed within the code and within the documentation. So that's what you send to the zBot hardware. Now the zBot hardware just sends out to you a JPEG image. We support multiple different protocols from the zBot hardware. We talked about the zCom, which is our simple protocol, but we also support the HTTP protocol. So you can simply connect to the zBot hardware and stream the JPEG images straight to a web browser. Now this doesn't do you much good because there's really nothing in the web browser that can decode the JPEG images and give you your, for example, analog to digital conversions. So for that we have the zCom protocol that goes out to a engine, and from there any sort of custom client can go ahead and take that data and present it to the user. Now we have the Java engine called the Z engine, and on top of that we have several different examples of how to use that engine. And one of the examples that I'm going to show actually has a GUI client interface as well as a web server, and on top of the web server it hosts all of the control and functionality down to the zBot hardware through a simple web interface. Here's some examples of what we've thought of as far as the different configurations that it'll be used in. Like if it's used in a tank configuration, you'll normally have 2 motors and a servo to control the camera. So your motors are controlled by the pulse width modulation to control the exact speed of the motors, while the servo controls the camera looking up and down. Now if you have a different configuration where maybe you have a little car, you have a pulse width modulation controlling the motor in the back, and then the servo controlling the wheels in the front, and then the camera somewhere in the middle. So with this configuration, obviously your control would be a lot different than just using two different motors to control it. And of course, if you're using a quadcopter, then you have 4 different motors to control via your pulse width modulation, and your camera would have to go somewhere in the middle. But you don't have to stop with just cars. You can use this design to build anything such as a weather station, an animal feeder, security cameras, or boats, or you can get multiples of these and put them onto one larger chassis, maybe one part controlling each function. We've put a lot of brains into the zBot itself, but mostly the zBot is just used for fast real-time processing of the video feed and of the analog to digital conversion, the interrupts, and all of that sort of stuff. So developing applications and programs at the embedded level is a lot harder than developing applications at the higher level, such as in Python or JavaScript or Java. So all of the heavier processing is done on the client. Now the client could be a Android phone, it could be a PC, a Windows or Linux PC. Here's a quick example of the Z Engine API. It takes care of the hard work of processing the JPEG and extracting all the data out of it, and it has callbacks and notifications for a Java application, so that you can easily write your own Java application to deal with the JPEG images and controlling the robot. So here's the PC example. If you wanted to connect to the robot, you would simply create a new instance of ComParser and give it the IP address of the bot that you're connecting to, and then you just block and wait for it to connect. From there you can implement an observer. Like here I've extended a JPanel so I can actually display the image, and then you can add the observer to the ComParser object. Then once you've added it to the ComParser object, all you have to do is override the update method. So if you're doing the same thing on Android, here's the Android example of how to use the Z engine. It looks pretty much the same, except for we have a TCP stream helper class on Android that we use to connect the ComParser. So from there we have a view class that extends surface view and implements the observer class. Basically, if you're going to be drawing images to the screen in Android, it's a little bit more complicated than it is in just PC Java. But you still just take the ComParser and you add your observer to it, and then you just override the update method. And then every time a new image comes out of the bot, your update methods get called. So we talked about how you receive the image from the bot, but how do you send things down to the bot? Well, for that you have commands. Now the commands use the same exact observer pattern, but they use it in such a way that it's really wrapped and simple, so you don't even have to deal with the observer pattern. All you need to do is create a new instance of the bot message, and then you can update the message to be whatever you want. Like for this instance, we would set the camera to resolution 6, which is 640 by 480, and then we just bot message send message. So you see, it's really simple to actually control any of the peripherals on the robot itself. If you wanted to control things like servos, it's just 3 lines of code.